Okay, students, we are going to do lesson 1.4 on the distance formula. So the distance between 2 points is the length of the segment between the points. So distance here, we've got one of our vocab words there if we want to highlight that. The coordinates of the points can be used to find the length of the segment. So we're going to talk about those different things. Some of it's going to be very basic today. Some of it's going to be more in-depth. And some of you are going to think like, I know what I'm doing, but there's some really good concepts in here. So distance formula on a number line is just simply that if P has a coordinate of x1 and Q has a coordinate of x2, then PQ is x2 minus x1 or x1 minus x2 in the absolute value symbol. So why do you think the distance formula uses absolute value? Because distances are always positive, okay? So a distance is always positive. It's something in geometry that actually throws you off in a lot of your other math classes, because we are going to ignore plus or minus values a lot of the times because all of our distances are positive. But you always want to remember that plus or minus is there when you're taking square roots and so on and so forth. Okay, so I will remind you of it a lot, but yes, it is the easy one where you don't have to remember it. Okay, the other piece that I missed here, because PQ is the same as QP, the order in which you name the endpoints is not important when calculating distances. Okay, so you can do it in either order. So that's the idea of the distance formula. So on a number line, very simple. If you are going to find distances, if you want to find the distance between A and E, A is at 5, E is at, -5, E is at 7, I'm just going to subtract them. So I tend to start with my bigger number. So I do 7 minus the -5. Okay, and it is the absolute value of that. So whichever way you wanted to do it, minus a negative is plus a positive. So 7 plus 5 is 12. And so I know that those are 12 units apart. So if we do that again, determine whether AC and BD are congruent. So you're going to check for the distance of AC and the distance of BD. Now, can you count these off? Yes, you absolutely can, especially here. So AC is 1, 2, 3, 4, 5, 6 units long. BD, we've got 1, 2, 3, 4, 5 units long. So are they congruent? The segments are not congruent. Okay, is what you would answer there. The endpoints of a segment on the coordinate plane can be used to find the length of that segment by using the distance formula. So here we have our distance formula. This is something that I would highlight in here so that we know that we've got this. We've found where it's at. But the interesting thing is that there are, I should count the number of ways because I always talk about this, but I don't ever give the exact number. I want to say that there are like 8 ways to write the distance formula. So I don't have one particular one memorized. What I mean by that is that P, so some random point that you start with, has coordinates of x1, y1, and Q has coordinates of x2, y2. So if you look at your distance formula is x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared, and it's the square root of the whole thing. So the different ways you can write it are, it does not matter if you do x2 minus x1 or x1 minus x2, because as soon as you do that, you're going to square it. And if these subtract to get 3, squaring that's 9, or if they subtract to get -3, squaring that's going to be 9. So to whichever order you want to do those in, you can. The same thing goes for y2 and y1, and you don't have to do both of these in the same order. So if you do x2 minus x1, you could do y1 minus y2. Now, again, I'm not giving that information to you to confuse you. I'm giving it to you so that you understand there's not one particular way to do this. So that does come up in this. The second thing that comes up here is that because once you do those parentheses, you square, you do your exponents, you're then going to add. And since adding can happen in either order, it doesn't matter if you do the x's first or the y's first. So you can actually put your x2 minus x1 squared second and your y2 minus y1 squared first if you would like to. No matter what, whatever you do with all of this, you take a square root of the whole thing in the end, and that is your distance formula. Now, for those of you that have looked at distance formula, like that is just an equation that just confuses me and whatnot, I would guess that if I were to ask you right now, do you know the Pythagorean theorem? Most of you would say, yes, I've got it down. If you don't remember Pythagorean theorem, it is a squared plus b squared is equal to c squared. So if you understand the Pythagorean theorem, I'm here to tell you that you know the distance formula. Okay, and you can, every single time I tell you use the distance formula to do this or find the distance between these two things, you can use the Pythagorean theorem. Okay, so here's how this goes. The Pythagorean theorem works for a right triangle. So I have a picture up here of 2 points, just kind of randomly placed. So wherever those 2 points will be, what I do is with that diagonal line, I form it into a right triangle. So I'm going to do that by from P either going straight up, straight down, straight left, or straight right to get in line with Q. So in this case, I can either go up or I can go left. I'm going to go ahead and go up just for the spacing. So I would go straight vertical here. And then from there, I'm going to go over to get to Q. And I'm making myself a right triangle out of that. Okay, now in doing that, I have formed my A, B, and C here, and you may or may not know which ones are which. But in this case, my A, to make it easy, I'm going to put my A up here, I'm going to put my B over here, and my C is this distance here. So there's my Pythagorean theorem with my A, B, and C labeled. Okay, and we have to talk about what each one of those are. Well, if I look at A, I'm going to start with that one first. Okay, A is showing a horizontal distance between where P is horizontally. So P is x1 units right. Okay, that's what this represents. It's right x1 units. And Q is x2 units right. So this is x2 that's over here. Okay, so what A is the difference between the x's that are here. So A represents x2 minus x1. Okay, now that should start to look familiar. You do the same thing with your y's. Well, if I come over here to B, the bottom of this is represented by how high is this point P, which is represented by y1, so it's y1 high. And the top of this point right here is represented by how high point Q is. That's y2 that's there. So that's my y1 and y2. So what is B? It's the difference between those. So B is equal to y2 minus y1. And then what does C represent? Well, C represents the distance we're talking about. So we're going to talk about the distance of PQ, and that is what C is. So C is kind of like our little d, if you want to call it that, when you're doing these, but I'm going to leave it as C for now. Okay, so if I start off with Pythagorean theorem, I would start off with a squared plus b squared is equal to c squared. What I like to say, if you're going to be using Pythagorean theorem, is that a squared is essentially your run squared, I'll get back to that, plus b squared is your rise squared, is equal to d squared is your distance squared. That's how your Pythagorean theorem is going to work with these. So again, what I mean by that is what I just went over here. So your run is how far apart are these 2 points, point P and point Q, run-wise. So horizontally are what the A is here. And we said that A was x2 minus x1. So my run is x2 minus x1. And that quantity I have to put in parentheses now because I want that whole run to be squared. If I don't put it in parentheses, only the x1 gets squared. So then plus my rise is my value of b that's here. So my difference in y's that are there. And so I'm going to fill that in again as I found it. Y2 minus y1, that quantity squared, is equal to, and again I have my distance squared, so I'm just going to leave it as distance squared. So the last piece to make this into the Pythagorean theorem is that you have to realize you're solving for the distance. So to get distance by itself, you would take a square root because square root and square cancel each other out. So that's going to get distance by itself. And if you do a square root of one side of an equation, you have to do a square root of the other side of the equation. And if you look right now, that is, this right here is your Pythagorean theorem formula that is written above. Okay, you can do that in reverse to show how distance formula is Pythagorean theorem, but from now on out, we're going to talk about this, but your distance and your Pythagorean theorem are exactly the same, and a lot of you are going to use Pythagorean theorem. Now, it is important to understand what is being written if it's done the other way, but you kind of get that grip. The biggest problems I see with students with the distance formula is understanding that there's a plus sign in here and the minus signs in there. They get those confused. So instead of thinking about it in that sense, I think about it as, okay, we understand Pythagorean theorem, so there's that plus sign. And then what is A? Well, it's the difference between the 2 points. It's how far apart those 2 points are. And so that's going to be a subtraction, and same thing with B. Okay, now that's a lot of information, but it's really important. So that was a really important little concept there. You can go look up more explanations of that if that didn't make sense. So let's use that idea and find the distance between J and K that are given here. So finding the distance between J and K, use the distance formula here. So if I use the distance formula, I'm going to set up a big square root, and it's going to be my x's subtracted from each other. Now, it doesn't matter the order, so 4 and negative 3. If you heard me say it earlier, when I subtract, if I can, I like to subtract my bigger from my smaller. So 4 is bigger, minus negative 3, that quantity squared, plus, now it's going to be my y's. So again, if I follow that same idea, 3 and negative 7, I'm going to do 3 minus negative 7 quantity squared. You cannot cancel out your square root and your squares. This plus sign in the middle is what stops you from doing that. Minus a negative gets to change to plus a positive. So my parentheses here becomes 7 squared. And then same thing here, that parentheses becomes 10 squared. So I can go to that next step. And then 7 squared is 49 plus 10 squared is 100. That's again still the square root of. I have to add those together first. So adding those together, I get 149, and I'm looking at the square root of that. And so that's going to be my answer there. I'm going to leave it at that. I don't think it simplifies. So that's going to be my answer. Now, using the Pythagorean theorem, how does that look? Well, I would start with a squared plus b squared equal to c squared, and it looks very similar. But you do a lot of the steps differently because you're kind of thinking about them. So A, we have to think about is our run. So our run between these two is how far apart are 4 and -3. So 4 and -3, and this is where you might use my number line in my classroom, are 7 units apart. Plus B is my rise. So how far apart are 3 and -7? So -7 and 3 are 10 units apart, is equal to c squared here. And then I can do 7 squared, which is 49, plus 10 squared, which is 100, equal to c squared. Add those together, 149 is equal to c squared, and now I can solve for c by taking a square root, and there's my answer, that c is equal to the square root of 149, and that c represents your distance there. So that's doing the same problem in 2 different ways. You can see how they're very similar to each other and what I did with them to go through those. Okay. Last one here gives us a snowboarding example, and this is just so that we have something to look after and kind of go again. So bear with me on this last one. Manuel wants to go snowboarding with his friend. The closest ski and snowboard resort is approximately 20 miles west. Now, we're going to be talking about directions a lot in this class. When we talk about and you see west, north, south, east, you can assume that they are at 90-degree angles to each other. And you do need to know which direction they are. So north is up, south is down, west is left, and east is right. It spells we. Okay, so that is your directions there. So ski and snowboard resort 20 miles west and 50 miles north of his house. So we're going to think about his house being at one place, and it says 20 miles west. So I'm going to go left 20 miles, and then I'm going to go up 50 miles is what it's giving us. That's going to be the snowboard and ski resort. Okay. And then it says that Manuel picks up a friend who lives, I'm going to change my color again, who lives 15 miles south and 10 miles east of his house. So south, so we're going to go 15 miles south and 10 miles east of his house is what we're going to do there. How far away are the 2 boys from the resort? So we're going to go to them and then to the resort that's here and find that distance. So if I'm looking at this distance here, I want to make kind of a large triangle out of this to make that right triangle and find the distance between his finished location and his starting location. And we don't care if it goes through his house, okay? So that's why we're not going to just count these that are here. But what we are going to count is what is this rise difference? Well, we did 50 miles here and 15 miles here. So this is 65 miles that way. And then what's our run distance? And we have a 20 and a 10, and so that's 30. So for this one, you would solve 30 squared plus 65 squared equal to c squared, and c is going to represent that miles. I'm going to leave it at that. You can solve it for yourself if you want.